Controlled environment plant production engineering technology education modules are developed and presented by The Ohio State University, Rutgers, the State University of New Jersey, and the University of Arizona, with support from USDA, NEFA, through their Higher Education Challenge Grant Program. This module is presented by Dr. Peter Ling of The Ohio State University, Dr. Jean Giacomelli of the University of Arizona, and Jetty Choi of The Ohio State University. In this module, we will discuss the topic of material flow and labor flow design. Flow is the transition between tasks. Mechanization and automation are a part of improving flow but are not covered specifically in this module. To learn more specifics about mechanization and automation, please go to the mechanization module. There are 4 learning objectives in this module on material flow and labor flow design. By the end of this module, you will be able to describe efficient use of labor, employ mechanization effectively, streamline the handling and movement of materials, and view an operation as a whole, not as a sum of parts. Our focus in this module is streamlining the handling and movement of materials between tasks. Efficient use of labor, a huge cost to growers, is accomplished by streamlining the handling and movement of materials. The first objective is to describe efficient use of labor. Improving labor efficiency allows for the operation to move faster and efficiently. To do this, evaluate which operations require the greatest amount of time and improve those areas. Let's note some common ways to improve labor efficiency. With respect to movement, travel distance and time can be reduced. Walking takes away a considerable amount of time that could be spent taking care of plants. Bottlenecks can be eliminated. Reduce the number of touches during production and maintenance. Use labor-saving devices such as hand tools, mechanization, and automation. Ensure a uniform crop. The consistency of a uniform crop will save time when working with the plants. Crop uniformity can be achieved by good climate control and watering. Here are some more ways to improve labor efficiency. Eliminate tasks by combining tasks. For example, combine soil mixing and pasteurization into one step by adding a steam line on a concrete mixer. Eliminate labor peaks and valleys. For example, balance out the heavy spring workload and low winter workload by mixing soil, filling pots, and dry seeding during the winter. One more way to improve labor efficiency is to provide a safe, comfortable working environment. Having a safe, comfortable working environment keeps the workers safe and able to perform to the best of their ability. Worker comfort and safety can be improved by adjusting machine speed to match worker speed, using conveyor systems, providing training on new equipment, and using equipment that will prevent strain on workers' bodies. When plants are not on benches, give workers a chair to help not strain their backs. Objective 2 is to employ mechanization effectively. Prepare mechanization by organizing the greenhouse layout, ensuring good transportation surfaces, building a well-trained crew and clearly defining responsibilities, identifying mechanically inclined employees for maintenance and operation, rewarding creative ideas, and having the mindset of continuous improvement. Here are some tips for equipment. Keep it simple. Use equipment that workers can understand the best. Select equipment that prevents bottlenecks. Find equipment that will allow for continuous movement and can pace the workers. Consider alternatives to equipment. Equipment can be expensive to own. Sometimes it can be easier to rent equipment or find a different system that can save costs. To use mechanization effectively, Mechanize repetitive tasks first. Use gravity to move materials. Feed bulk materials by gravity through bins or hoppers to potting machines. Materials heavier than 50 pounds should be moved mechanically to avoid tiring. Use forklifts, wagons, conveyors, or carts. Standardize containers, mixes, and methods. Limit container sizes and manufacturers. Limit the number of growing mixes used. Standardizing methods is important so that there is no confusion between workers and the plants can get proper treatment. The reason to limit containers and growing mixes is to allow for more efficiency so workers aren't searching through various containers and mixes for the ones they need to use. An operation can only move as quickly as its slowest component. Make movement continuous. Adjust machine speed to match worker speed. Bring work to the worker. Connect pot, flat fillers, dibble machines, and potting operations using conveyors. Use an assembly line for potting. The third objective is to streamline the handling and movement of materials. Let the layout of the greenhouse allow for efficient transportation. The picture in the upper left corner shows poor material flow due to the long, narrow aisles where only one worker can pass through at a time. The picture in the lower left shows a cart. Using a cart, one worker in a narrow walkway can carry more than one plant at a time, increasing transportation efficiency. Set up one main pathway with several pathways connecting to it. Have work areas near the production area or far away. Having the work area nearby will allow for a shorter distance of transportation. Having it far away will help reduce human traffic jams around the production area. Make materials easily accessible. Here are some material movement guidelines. Move materials as short a distance as possible. Keep delivery and shipping traffic out of the work area. Store materials in or on units that are easy to move. Place materials stored outside in an area with good drainage and easy equipment access. Store levels, seeds, hardware, and other tools in bins or racks for inventory control. Move materials as close to their point of use as possible. Much time can be spent moving materials and supplies from one location to another. In the picture, you can see not only the cart, but also the concrete walkway for easy cart movement. It will be difficult to move carts on gravel or dirt floors. Also, the plants are growing on the floor. This is harder for laborers who need to bend over to work on the plants. Growing plants on benches is more labor efficient, but more expensive due to the cost of the benches. We will now introduce the concept of lean flow. The quest to become more lean is common in industry today and includes the concepts of material flow and labor design. The focus of lean is on maximizing product quantity while eliminating wasteful practices. Lean pushes for the minimal amount of hours and the best product output. For example, in an assembly line, the first worker will do the cleaning, the next will tag and label, and the third worker will go store. Becoming lean is heavily dependent on employee involvement. It is not possible to optimize material flow for an entire operation at once. Becoming lean is a cycle of continuous improvement. Here are some case studies of businesses that have successfully become more lean. I say more lean because a business should never stop making improvements in material flow and labor design. In Arcadia, Florida, implementation of progressive work during the packing process allowed for a 25% increase in production and an optimization of floor space. At Van de Watering, the lean method is revised to a progressive sticking method, where workers work in teams to complete the trays. Production was boosted by 20% within 2 hours. Here is a list of the lean flow top 8 violations. Producing more than is needed or before it is needed. Time wasted on waiting. Unnecessary motions or movements by people. Keeping excess inventory that is not being processed. Unnecessary transportation of products and materials. Performing any activity that is not necessary to produce a functioning product. Producing defects in products or services that require resources to be corrected. And lastly, failure to utilize employee skills in the processes. An acronym to use to easily remember the violations is downtime. How does a grower identify bottlenecks? The bottleneck is the slowest part of the production. Identification is important because bottlenecks create inefficiency and therefore waste. Equipment, staff, or the task itself could be the bottleneck. Common areas of bottlenecks are pathways that are too small for transportation, not enough space for new shipments, and poor material flow and organization of workspace and work patterns. Organization is important to help reduce human traffic jams in the greenhouse. In the picture, the cart is used to very efficiently move plants in the main aisle, but the transportation bottlenecks as the workers walk the trays down the narrow aisles one at a time. Seasonal bottlenecks occur during busy seasons. In the spring, there is a higher workload and things like maintenance may go undone. In the winter, there are too many workers with very little to do. Balance the workloads by prepping spring work during the winter. For example, workers could mix soils, fill flats, and pots. Another type of bottleneck is an automation bottleneck. High outputs produced from automation can cause a traffic jam later down the line. Set the machine setting at a pace workers can catch up to and avoid traffic jams. Marking and labeling is important to be able to find plants and materials. This will save time for the workers looking for materials. Clearly and legibly mark materials. Be sure to use water-resistant tags when needed. Use a computer to track the quantity and location of plants. Software solutions for this are available and can be made to work with barcodes or RFID tags. Let's talk about crop specialization. In the picture below, we see a greenhouse dedicated to tomatoes. Greater efficiency is achieved where only one crop is grown. Keeping employees stationed to a single area boosts labor production. Where only one crop is grown, plants are easier to maintain with less special treatment. This allows for the greenhouse climate and watering to be uniform. Objective 4 is to view an operation as a whole, not as a sum of parts. The greenhouse as a whole is a complex system made up of biological and mechanical subsystems. Subsystems are deeply interrelated and must function together for a successful crop production. As shown in this picture of a hydroponic garden, there are many subsystems, such as the anaerobic digester, the heating system, the cooling system, and the water filtration system. Do not view these systems as separate pieces of the production system to maintain and improve individually. Instead, view the system as this schematic diagram is presented here. The efficiency of one subsystem will affect all others. In the greenhouse, there are two kinds of logistics: production and shipping. Growers need to worry about the cost of delivery of the product. To minimize the cost of shipping, some growers will route the order for most efficient use of time and miles. Managing inventory is important in order to have enough plants on hand, manage the sales, and know what will be grown for the next season. One last time, we will emphasize that a grower should examine labor, materials, and mechanization with respect to an entire operation rather than as separate components. Refrain from improving an irrigation system or a potting system just for the sake of a better irrigation system or a better potting system. Improve the irrigation system for more uniform crops, or improve the potting system because filling pots is a production bottleneck. Efficiency is the key to production. With efficiency, production can increase by labor, materials, and mechanization. Thank you for viewing.